Hey everybody, this is Larry. This is day 25 of the Leetcode Day Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about, well, today's forum and how y'all doing and everything. There's a red dot here. I don't know what that means. Oh, try new features. I'm not going to do that. I want the old feature back, in fact. But yeah, today I finally was able to hit up the gym. I did squats. My foot still hurts, but it's stable enough, I think, to do squats. I don't know. We'll see. But I only did it up to 185 pounds. It's not scientific. I was just doing two 45s and then two 25s on both sides to hit 185, I think. Unless my math is wrong, then I'm really embarrassed. But I think that's right though. But 90 plus 50, 140, 175 maybe. I don't know. No. Wait, what? I don't know. Whatever. 185, 175. What's that in kg? Like 82.5 kilograms, something like that. Kg. I don't know. Something like that. I didn't really. It's my first squat session in like 2 months because of injury. So I was just happy to kind of just get my muscle flowing, and I have ways to go, so I'm not really worried about it. Remember, and kind of just going back to Leetcode, right? Sometimes just have to set reasonable expectations. It doesn't, like on a day-to-day basis, how you get better, how you get measured, how you get improvements is not on one data point, one entry, one whatever, right? Is your work over time, is your progression over time, it is all the time and all the painful things you put in over time, right? It's not just one event. Unless you're injured that event, I guess, but that's another story. So yeah, so I'm pretty happy about it. Running is still a little bit tricky. I guess I didn't talk about it the other day because it was, that was during the contest day, which is always a lot of videos. I ran a couple miles the other day, but I also tried to run, like a stride, which means that I was like not quite sprinting, but trying to go fast, but it was very painful for my foot, so I gave up after like 25 seconds or 20 seconds or so. Oh no, I went 200 meters, so it must have been like 45 seconds or so for 200 meters. Not very fast, but it was very painful. So I'm still kind of trying to gauge how to run. I have a race in, I think it's this weekend. I gotta double check actually, because, well, it'll be sad to miss. All right. That's 3 minutes of update. Hopefully, because I feel like sometimes when I don't do it, people ask me about it. So I don't know. If I'm updating too much, let me know in the comments. I don't know. I think I bring it back to Leetcode from time to time. So I think I know a lot of people watching my videos. Generally, well, if you're dominating it, you're probably not watching it that much. So a lot of the times you're watching it because you're struggling. So I just want, the reason why I tell you about these things is because these are the things that I'm struggling with, right? So yeah. And I feel like it reminded me of that quote that comes up sometimes where like someone's like, how does that go? Like the first day you step into the gym is the smallest, you feel like you're the smartest in your life or something like that, because now you realize how big the world is, kind of. And it's the same thing with Leetcode. You when you're in the beginning, you may not know that you don't know it, but then when you look at the rate, okay, ChatGPT stuff aside and the cheating aside, look at the rating, you're like, wow, some people are really good. And I get a lot of these comments, maybe not as much anymore, at least not recently anyway. But I get comments of like, wow, you solved this problem in like 25 seconds, you must be cheating. And I'm like, no, you can watch me on video. Also, the problem is like 3-4 loops, for a Q1 or something, or if I did like a Q3 in 5 minutes or something, right? Of course, nowadays there's actually a lot of cheating, so maybe people are just like, well, it is what it is. I don't know, right? Where at least back then, like, I don't even know how you would necessarily cheat unless you've seen the problem before. I mean, that's not even cheating per se, but I just mean like, I don't know, if someone gave you the palm earlier or something, I don't know, right? Anyway, all right, that said, let's take a look at today's problem. Today we have 1524, number of sub-arrays with odd sum. Given an array of integer or return the number of subarrays of an odd sum. I did see the mod while I was talking. That's why I typed out the mod thing. I always have a mod. Maybe I need a proper mod song so I don't forget the mod. The reason why is because I forget the mod a lot. So I always write it out first in a way such that, like, I know that when I return, I have to edit this, and I'm like, oh, there is a mod, so I don't forget it. So that's the reason why. I already make too many silly mistakes. But in any case, okay. Subarray, right? So this is kind of a very classic problem, and definitely a very good problem, I think, to get learning on prefix sum and dynamic programming in a way. I think the first thing I would say about this problem is that I would think about, the first thing is that n is 10 to the 5th, just to be clear, so that n square solutions are not fast enough, right? When did I okay, so I haven't done this video in about 4 years. That's good, because I want to spend time on this video, but if I did, like, last year, then maybe I already explained it well enough. But yeah, so the first thing I would say beyond the end thing, so I guess the second thing after that would be contribution, right? It's something that I came up with in terms of explanation maybe the past year or so. So I don't know if you see it in any other place, but the way that I think about these problems is that for each element, there is its contribution to the answer. Actually, I was going to do some ASCII art thing, but let me actually just bring up the drawing board real quick. All right, and then the idea is that, okay, what are the okay, it's just 1 2 3 4 5 6 7. It's kind of a little bit lazy on the examples, but it would have to do. You have 1 2 3 4 5 6 7, right? And then the idea with contribution is that the contribution itself is just that given a certain number, what is the contribution to the final answer, right? And that's a very generic way of saying it. This applies to sliding window type problems. This applies to a lot of different problems, and that's why I kind of want to group them together. Is that it's just basically given an index, a number, what is the contribution? And then the idea here is that hopefully, in some way, as you kind of scan from left to right, moving from this contribution to this contribution, you're able to reuse things that you've calculated before to give you a performance boost, right? So like maybe if you do something incremental, O of 1 or O of log n or something like that, and some of this, and it could be amortized as well, right? I mean, it doesn't apply for this problem, but for example, you have some sliding window, then the contribution is maybe either the length of that window or things that are inside the window or something like that. And then when you slide off the window, then you have an amortized O of 1, right? But anyway, that's not the case here anyway. But yeah, so that's the first thing I would urge to think about is this idea of contribution. And then the question for me, there are a couple of ways to think about this also. On the next idea is this idea of symmetry, right? The way that I usually structure these problems is that for the what I call the current index, I try to look only backwards. And the reason why I do that is because it's just easier to say is the first reason, because then now you could say, okay, what is the contribution? Instead of just 3 as the contribution, I could say what is the, sorry for the terrible handwriting, the contribution where the last element is 3, right? Is 3. So then now 3 is the last element, then you're gonna look back. And the benefit from this is that instead of, and you can also look just forward, but then in that sense it's just backwards without loss of generality, right? But the reason why you don't want to go kind of both direction necessarily, where 3 is in anything, because for example, maybe 3 and 5 could be a thing, right, or whatever, right, is that this way is very easy to handle double counting, right? Or maybe it's not easy, but it's simple. Or the idea is having this consistency is because then now 3 can be the last element only, like it can only be the last element I want to say once, but that's not quite right, is that it can only contribute to the answer once where it is the last element, right? Because even if this 3 is part of some answer that has, maybe the answer is 4, 3 or something, so 3 is in there, but you don't count it because, like I said, because of this, when you articulate it this way, then everything gets only counted once, right? Because we don't care, or necessarily we don't care about 3 in the other places. So yeah, so that's why I kind of structure it that way. Okay, for this one, what was it again? Sub array odd sum. There are things we can play around with, but but the idea here is the first idea is just having, I keep saying first, but I guess it's like the 5th idea by now, and you can see that this is kind of getting a little bit hard, right? I mean, it's not hard, like all the components, I hope that you can understand the components, right? But you could also see that you have to put all these things together, and it gets a little bit tricky for sure. But the next idea is prefix sum, right? I'm not gonna go with prefix sum in this video too much, but the idea of prefix sum is just that you get the sum from some prefix, right? So maybe you could think about it as line segments as the things, right? So in calculating the prefix sum, you're calculating the line segment with 0 length, 1 length, 2, 3, 4, 5, 6, 7, right? And so you're basically given these line segments, and with these line segments, an idea prefix sum, you can think of it as an array anyway, but I like to do it this way, is that that means that any line segment can be represented with any other line segment that's a subarray between any 2 points can be represented by 2 of these line segments, right? By subtraction. For example, I don't know, I'm gonna draw a random line from say 2 to 5 maybe? I don't know, whatever. From 2 to 5, then basically this line is just equal to, okay, well, we'll pretend that they line up a little bit better because I'm terrible at drawing. Then it just means it's this one subtracted by this one, right? Because then this, I mean, you could probably just draw it out visually, is that this line minus this line equals this line, right? So that's basically the idea behind prefix sum really quickly. You can kind of play around this idea. I don't have to draw you everything. I feel like people at home are smart, but you can play around this idea in that's basically how you get any line segment, right? So that's prefix sum. This one is a little bit tricky because now, okay, let's go back to the contribution thing real quick, is that, excuse me. Is that, okay, let's say we're at 5, right? Then now, how many subarrays ending, the contribution question in this problem would be how many arrays, or how many subarrays ending in 5 has odd sum, right? So then now, what does that mean, right? Well, so now if you want to think about prefix sum, you have this line segment that we drew before, and then now we want to ask, maybe we call it P sub, I don't know, P sub X, I don't know, right? And then now we want to subtract it by some length, and it's a wavy length because we don't know how long it goes. So minus some P sub I, some previous prefix sum is equal to 0, what is it? Oh no, it's odd, right? Sorry, whoops. Then it's 1. But I mean, same idea either way. That's why it doesn't really matter. 1, how do I write under 2 again? I think it's congruent under 2, mod 2 or something. I forget the mod symbol. I think you just write 2, right? So that's like the idea, right? And of course there could be multiple of these, but that's the idea. And there's some initial maths that you can do, right? Because given that this is mod under 2 and this is a subtraction, you can say you can mod 2 on both this element and this element, right? Just some basic stuff because it is congruent over the equivalence class, right? And then so then now, I mean, there are ways to kind of do this in a slicker way, but I'm going to show you something that's even more, I suppose, basic, right? is that, well, how do you get a 1, right? Well, as we said, because of this mod 2, we can maybe rewrite it as something like this. Mod 2 minus, it's not quite right because you still have to mod 2 over the entire thing. But you'll see why I write it this way in a second, right? Right? The reason why I write this in a second is that then now there are only two cases, right? One is that, okay, p sub x is equal to, p sub x mod 2 more specifically, is equal to 1, right? If this is 1, then you can, I could manipulate the subtraction on the other side, subtract 1 on both sides, I guess, or whatever. But you're smart. That means that p sub I mod 2 has to be equal to 0 for this to be true, right? And then also conversely, inversely, maybe, I don't know, maybe, I guess technically converse and inverse is true for this one. But anyway, yeah, if p sub x mod 2 is 0, right, then, then p sub I mod 2 is going to be 1. And then now we just have to count, and we know that this happens possibly more than 1 times, possibly 0 times, right? Any number of times. So we just have to count all of these out. And that's really the idea behind this problem. And of course, you can play around with different ideas similarly, and there are probably like cleaner ways to represent it. But I think this is like in code and stuff like that, and you see people with really clever code or whatever. But this is the idea, right? This is the idea of yeah, that's it. And from that, you don't really need anything else. I know that you can get fancy with the implementation, but for today, I'm going to be just keep it basic as what we said, right? So okay, so we have two things that we want to keep track of, right? Maybe we want a previous 0, right, is equal to 0. Technically, I guess that's not true, but we'll talk about it in a second. Previous 1 is equal to 0, right? And then now, keeping in mind that the subarray of 0 elements, right, the empty set. So you want something like, okay, well then here we have 1 to kind of denote the empty set, to count all the stuff in between. And with this problem, it's for this problem, it doesn't matter. You could be a little bit sloppy. And what I mean is that if this is even sum, then you have to keep track of, or you have to remove the empty set, right? Because technically it's true that an empty subarray has, but you have to be careful about stuff like that. But obviously there cannot be an empty subarray with odd sum, right? Just because 0 is not odd. I mean, that's the idea. Okay, so total is the total count, right? So okay, and then now we have for x in array, and also maybe I want p for prefix, right? It starts at 0. Here we want to add it to x, right? And then now we want to include this element. So this is p sub x now, I guess, if you want to keep the same notation. And then now we want to look for all the p sub i's, right? So here, oh, and of course we have to mod by 2, right? And then here we said, like I said, I know there are cleaner ways to write it, but I just want to be explicit today. But p sub 0 is equal, p is equal to 0. Then now total, we want to add the number of previous 1, right? I mean, we kind of showed it, so hopefully I'm not skipping too much. And the same idea here is that if p is equal to 1, then we want to match it with the things that are 0 previously, right? And that's really it. Yeah. Oh well. Well, now we have to kind of keep track of things. Yeah, right. Because this, now we have to update previous, because now that we're done, we want to set it on for the future. So if p is equal to 0, previous of 0 we increment, and else previous of 1 increment. And I know you can combine these, but I just want to be, beginner friendly. I mean, I didn't forget the mod, but I forgot to return the answer though. Yeah. Okay. Oh well. I mean, at least I didn't submit it, so yeah. But that's basically it. That's the whole idea. Let me know what you think. This is one of my longer videos because I really want to break it down. Let me know what you prefer. I mean, it's not always, frankly, it's not always possible for me to do this for every problem, because a lot of problems are very similar, and it just kind of wastes my time at some point, especially if you have a week of it. But hopefully this is kind of illustrative, and hopefully I don't have to go over the complexity too much. We have constant space, right? We only have like 5 variables or something like that, and we linear time for also obvious reasons of we look at each element once and do some fancy additions and a mod, and that's it. And yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. Join the Discord. I'll see y'all later and take care. Bye bye.